Okay, so hopefully I'm going to go into some use cases, and hopefully this will allow you to build up a picture of some of the different ways how the Megaport Virtual Edge can benefit different types of solutions and different types of SD-WAN deployments. Okay, so here's the first one, avoiding cross-country hairpin. So what often happens, as I touched upon earlier, is that branches are connected over IPsec tunnels back to a data center, and then they're typically sharing internet connectivity to one or multiple clouds. So this could mean that the branches are traveling over a long distance to reach a data center, and then they're going into a suboptimal cloud that they are traveling a long way to get to, and then all of that traverses back across the network as well. They have to pay higher egress fees out of the clouds at the same time as well. If you introduce a Megaport Virtual Edge, there's a number of different benefits. So the short hop to the Megaport Virtual Edge, then the branches are now free. They are free to go directly to cloud. You can have them sharing a cloud connection if you want to do it that way. But let's say you've got one of these branches that has your top developers, they're doing large bandwidth testing, and you want to keep them separate. You can spin up a separate connection for them towards cloud so that they have a dedicated connection, put them into different VPCs. They're not going to affect any applications or workloads that you're using. The other benefits here are that the virtual edge allows you to get back to the data center entirely private, because now you have a physical port inside the DC, and that's an entirely private connection out to the virtual edge. And indeed, between the data center and the cloud is now entirely private connectivity. So that's a great benefit there. And of course, the lower egress fees that you'll see with this solution. Another one is Multicloud VPN Tunnels. So if you are deploying in multiple clouds, we're showing AWS and Azure here, you'll typically have IPsec tunnels running from your branches into the cloud. And then inside the cloud, you'll put in a transit VPC to host the different virtual edges that you need there. So transit VPC in AWS, transit VNet for the Azure terminology. You'll typically deploy multiple elements of those to give you resilience, and then you'll have IPsec tunnels going out from each of those to each of your branch. So this gets cumbersome to manage. It can be difficult to reach higher bandwidths across this as well. And then when you want to do cloud to cloud, you have to do additional IPsec VPNs as well between those. So that is suboptimal, and again, higher egress fees. If you introduce a Megaport Virtual Edge, or even multiple virtual edges for resilience, you connect into that over a short internet hop, then you've got that private connectivity option into cloud. You do away with that transit VNet so that you're bringing that routing functionality out to the Megaport Virtual Edge. The additional benefit is, of course, the lower egress fees, but also you've got an entirely private cloud-to-cloud connection there between the two clouds. And you can do this with all of the cloud providers that we have on our network. So that cloud-to-cloud is optimized. You can scale it to the size that you need to have for your workloads and applications. And it won't touch the internet at any point. And you've got, of course, the lower egress fees there. Great. I've just got two more. This one, use case 3, so middle mile optimization. It's a little bit like the first use case that we saw, which was not optimized going to cloud. But this one has branches in two locations. So let's say West Europe and East Europe. The traffic, again, is not optimized. It's going back to a data center and sharing connectivity to cloud. And then that branch-to-branch communications, again, over longer distances, will give users a suboptimal experience. So they could benefit with a better network connectivity and having a private core between those elements as much as possible. So introduce Megaport Virtual Edge. As we can see here, one in West, one in East, but we've also got a physical port inside the data center. So, reach us in one of our 800 data centers globally, spin up that port, physically connect into the port, and then you've also got access to everything on the Megaport network, including that connectivity to cloud. Now you can see in this use case, let's take the West branches. They no longer have to go to the data center before going to cloud. They can go through the MVE and go entirely directly to the cloud providers that they want to in their region using those private interfaces. They can, of course, go back to the data center for anything they need to access there. They can also go to the East branch locations and also into the clouds in the East that are being used over there as well, should there be some requirement of an application to do that as well. Okay, and then it's the same as true for the East branches. So now we've freed up these branches to do what they want with cloud, connect locally, connect into the data center as required, and then connect to each other with much better quality, giving a much better user experience. So the final use case that I've got is virtualizing remote POPs. As we get on customer calls, we often hear our customers telling us, I've got 20 data centers. I want to bring that down to 2 data centers in each region. I want to remove that burden of data centers in remote regions that I don't need to be in. So in this example, there are branches in APAC, branches in EMEA. They're connecting into a data center purely for communications reasons. And then they're also going back to a data center, a physical data center in the US, in North America. By introducing the Megaport virtual edges in APAC and in EMEA, you're essentially virtualizing that data center. You can remove your footprint from those DCs, deploy the Megaport virtual edge, but you're still keeping a footprint inside the DC, closer maybe to your headquarters, but you're removing that requirement to have that in those other remote locations. You can spin up that Megaport virtual edge as you wish. Remember, you do not have to be inside that data center to deploy a Megaport virtual edge. You don't have to deploy a rack, take power, go into a long-term contract. You just spin up the virtual edge, deploy your SD-WAN license on top of that, and then start connecting it to whatever you want on the Megaport network. Okay, great. So let's just take a look at 2 customer reference scenarios. So the first one is a customer who's deployed across 3 regions, predominantly wanting to get into Microsoft Azure, but also other clouds as well. Now, this customer wanted to have dual underlay, so being able to connect across the internet and across an MPLS network at the same time. So in each region, they've deployed multiple Megaport virtual edges and multiple physical ports. The physical ports getting them the MPLS underlay and the ability to connect into the MVE infrastructure and then off to cloud as well. And there's also region to region connections, Americas to Europe, Europe to APAC, APAC to Americas, going around the globe over our resilient global network that is in place for all of those connections between the regions. Okay, so that's a logical view of that customer deployment. Let's look at it from a geographical point of view, because it's probably easier to visualize for many of us. So in Europe, deployed in multiple locations with a Megaport virtual edge, so separate data centers in Amsterdam. And then the branches are connected into both of those Megaport virtual edge locations in Amsterdam. We're just showing it going into one now for simplicity, but it does, of course, connect into both of those for resilience. The same is true for Singapore. So 2 deployments in Singapore. They're in completely separate data centers for high availability and resilience. And then in North America, the deployment is in 2 separate metros. So one is in Ashburn and one is in Atlanta. And the branches will connect to the nearest one, but also has the ability to connect into a further away one should there be a failure with that point. These, of course, then are all joined to each other to give you that region-to-region connectivity over resilient connections. And then added into that are the connectivity options to cloud. So I'm just showing Azure and AWS here for each of the regions. They're connecting into their local clouds, but there's nothing to stop branches in Amsterdam going to their local MVE and then reaching a cloud in any other region around the globe. And then finally, to get that private underlay as well, there are physical ports deployed in multiple data centers within each region as well. So physically separate data centers to give additional resilience there as well. So really nice solution there. The second one that I have is really around a company who has branches all over the US. They're connecting those branches into data centers in Las Vegas and Reno, and they have a suboptimal experience. They're going across a long distance and then sending back their traffic again, and they're going into clouds in a faraway location on the West Coast. We introduced Seattle, Toronto, Chicago, and Atlanta Megaport Virtual Edges, which means now these branches go to their local virtual edge, connect into their local cloud provider, but they can also get back to the applications they need to in Reno and Las Vegas over a private network. So 98+% of their journey is over that private network. And if they need to, they can actually access the cloud on the West Coast as well. So a really good improvement of the user experience for these customers when they deployed this. So they had over 1,000 branches, collect them into the nearest MVE, connect them to the locust cloud, and then use our backbone across the US and from Canada to get to Reno and Las Vegas to those physical data centers. Nice one. So the next, the final piece that I've got for you here today is really the support for your journey to SASE. So the Secure Access Service Edge was a term coined by Gartner a few years ago when they launched their article on this, really highlighting how you should securely deploy your network. So there's two elements to it. There's the network as a service side, which obviously Megaport firmly fits in. And then there's also security as a service here on the right. So we are here to bond these two together. We, like I said before, we are not selling SD-WAN solutions. We are hosting that SD-WAN element on the edge of our network, allowing you to get that network as a service, that flexibility, that control, to have that private connectivity. However, all of the vendors that we saw earlier, Cisco SD-WAN, Fortinet, Versa, VMware, Aruba, all of those have SASE solutions today. So they're all providing the elements that are required, and we are the enabler that ties all of that together. In this diagram, I've basically put in bold the different elements that you need to have in a core SASE solution according to Gartner. So you need to have the cloud access security broker, the cloud secure web gateway, zero trust network access, firewall as a service, and of course, SD-WAN. So that's where we fit into that. And of course, we work with our partners very closely for customers who want to deploy SASE solutions based on the SD-WAN provider of choice. So just summarizing what we've covered so far, we've got, before we go into the Q&A, we've got customers who want that real on-demand solution. So enterprises are looking for more of that today, being able to control things easily through a portal or indeed through automation. You can simplify a lot of your deployment through configuration, through automation tools, such as Terraform, for example, allowing you to connect all of your cloud VPCs together, your branches, your data centers, and branch to branch, and giving you the ability to have private multi-cloud as well, where cloud to cloud, which we know is extremely popular for medium and large enterprises, but you can have that entirely privately without touching the internet at all. And of course, underlying all of this are the security elements that come with your SD-WAN solution, but also the low latency that Megaport will give you across the network, as well as excellent jitter figures, a better user experience overall, especially as you deploy that SD-WAN network across the region and across around the world.